Hello everyone, today we're here to talk to you about fluidization. Before we start, I would like to introduce my own team. First, my name is Pairin Daotong.
My name is ชยากรทุติยสกุล
My name is Thitilachoya Mongkol.
My name is Patharawadi Champadi.
First, we're going to overview this presentation. This presentation starts with objective and follow with theory of fluidization, experiment, result and discussion, conclusion, and finally application of fluidization. Let's go to first topic. We select of fluidization to study behavior of fluidization in air solid system and to study relation of velocity of air, pressure drop or pressure difference between initial and final in bed and initial height of bed. And its main objective we choose fluidization to present is fluidization can save energy in chemical process industrial and able to respond the needs in the case of production and more efficiency.
Next, theory of fluidization. Fluidization is a condition when the fluid passes above the solid particle bed with suitable velocity to make the particle behave like suspension. This slide shows the relation between superficial velocity versus pressure drop and bed height. At point A, illustrate the gravity force at the pressure drop, then increasing the velocity of fluid until it enough to move the particle at point B. In this state, the fixed bed becomes the initial phase of fluid bed. For B to C, the pressure drop is constant and the height of bed is increasing. In the other hand, the pressure drop of C to B is constant and bed height is decreasing. Fluidization is divided into two types, consist of particulate fluidization and aggregative or bubbling fluidization. For particulate fluidization is carried by liquid and consists of fixed bed and particulate fluidization. For bubbling fluidization is carried by gas, consists of bubbling regime, slug flow, and turbulent regime. The important variable of fluidization is minimum velocity, terminal velocity, and void fraction. We can calculate the minimum velocity from this equation that derive from Eigen equation. Substituting the variable into the equation, then we got the value of minimum velocity that is 2.176 meters per second. We calculate the Reynolds number to find the characteristic of fluid flow. For selecting the equation to calculate the terminal velocity, then we got the terminal velocity at 19.15 meters per second. We can calculate void fraction from this equation, and we got the value of void fraction that is 0.262.
These are equipment that using in our experiment composed of digital anemometer, valves, scales, column, manometer, and the last one is blower. So for the methodology, first, we have to determine the two important values, which are diameter of the particle, by measure the wide length height of the rate band and put this value into the cubic root. In consequence, you will get the particle diameters. And the density, measuring by selecting the amount of rate band to veining first and putting them in the beaker that you have already at the water and observe the level of water that increasing. So to determine the value of density, you have to bring the mass that you're weighing at first divided by the level of the water that increasing, and then you will get the value of density of the red bin. After that, you have to put the amount of the red bin into the column and measure the height of them. Next step, you have to preparation the in your experiment by open the blower and open the valve 1. If you're ready to do the experiment, you have to gradually close valve 1 and gradually open valve 2 to let the velocity into the column, following by the red arrow. And then you have to observe the minimum velocity that makes your red bin moving up. After that, you have to increase the velocity airflow slowly. If the red bin moving up beyond the top of the column, you have to stop your experiment and do the conversely by decreasing the velocity of the airflow until you encounter the minimum velocity again. So the value that you have to record from these experiments, which are height of the red bin, velocity of the airflow, and the difference of pressure in your manometer into your result data. And for the next, you have to write your conclusion and your discussion respectively.
Result and conclusion. Finding minimum velocity according to Eigen equation. Experiment data can be defined by relationship between pressure drop and velocity of airflow, and relationship between bed height and velocity of airflow, and relationship between wall fraction and velocity of airflow. From graph 1, show the relationship of pressure drop and velocity of airflow. At initial, pressure drop immediately increased until the particles were began to move until the minimum velocity. After that, pressure drop started to be constant because the air velocity does not affect with pressure drop. Likewise, when reducing the air velocity continue down, the pressure drop is decreased steadily. From graph 2, show the relationship of bed height and velocity of airflow. At low velocity, the height of bed does not change, and when increase the air velocity, the bed height is moving and continue increase until the maximum velocity. When reducing the air velocity and become to fixed bed again, which the height in is greater than the height before the experiment begins, because the expansion of the base caused not to be compensated as in the beginning. From graph 3, show the relationship of ball fraction and velocity of airflow. When the velocity of airflow is increased, the wall fraction will be increased because the high velocity of airflow make the beams dispersion because there is damp force acting on the particles. When the velocity of airflow is decreased, the wall fraction will be decreased. From table compare the minimum velocity from theory equal to 0.16 meter per second and the minimum velocity from experiment equal to meter per second. So, percent error of experiment equal 8.8%.
In part of application, can use widely in processing industry. Example, separation, drying of solids, absorption of gas, combustion of coal, catalytic regeneration, and the main advantage of fluidization is good mixing of solids, high heat transfer rate and easy to transfer solid from one to another. In part of this advantage, uneven contracting of gas and solid, an erosion of vessel internal part, and finally interaction of solids. Thank you for listening patiently and attentionally.